Welcome back, Ratana. First one back.
Hello.
Well done.
Yep. First one come back.
Everybody have breakfast?
Hello. Yes, I have already.
Yes. What did you have for breakfast, Lavin?
Noodle.
Noodles. What flavor? Chicken? Beef?
Just chicken.
Oh, chicken. Okay. Soklang, what did you have for breakfast? A cup of very strong coffee, by the looks of it?
Sandwich.
Sandwich. What was in your sandwich, Soklang?
Egg. Hot dog.
Dinosaur.
Dinosaur?
What?
You didn't have a dinosaur sandwich?
No.
Oh, you put dinosaur in the sandwich. I never hear that.
That would be a very big sandwich, wouldn't it? A dinosaur sandwich.
Yeah.
Big.
Waternak, what did you have for breakfast?
Nothing. I haven't eaten yet.
Oh.
We died.
Ratana, what did you have for breakfast, Ratana?
You want to know something?
What?
I close my camera and I eat my breakfast in the supermarket room.
Oh, really? You were eating
Yep.
your breakfast during the Superminds lesson.
Yep, it's real.
What did you have? Let me guess. A tube of Pringles.
No.
No?
He likes Pringles.
Yeah, he does like Pringles.
Epic Pringle.
Yeah, what do you have for breakfast?
I just had a cup of very strong coffee.
Coffee?
This.
Coffee.
I don't normally eat until the afternoon, which is very bad. You should eat breakfast. It's very healthy to eat breakfast, but I'm never hungry in the morning.
That's gay. No cap.
Hmm?
How can what and I get the plushie?
Thanks. Thanks. I mean it really. Thanks, Hawk. Thanks for giving me the G word.
What is gay? No cap.
Yeah, can you mute Chai Hawk? So annoying.
Yeah, he's so annoying.
It's not him. It's not just him that's annoying. His personality is also.
You're the one who's annoying. I told you to get the jetpack and you don't get it until the third time.
What why you guys don't why you guys don't insult each other?
What's the chairs here?
Why do you always roast each other?
Yeah, I don't know. Yeah. When we call the group, he always like mad at each other. Hello, you stupid ass.
What happened with him?
Only true friends insult each other.
And plus,
Yes,
and it's
that's true.
Wow, Coco Melon. Peppa Pig no channel. Peppa Pig goes up and down. Peppa Pig official channel. Peppa Pig friends and
What the hell is this two girl?
Right, okay.
Ew,
Mute
this
everybody. Bye-bye, everybody. Right, we're going to start by watching a video today. You can either watch it with me on the Zoom, or if your internet is not very good, click on the link in Telegram. Okay, we're going to watch a video about reversible and irreversible changes. Remember, it's to do with science. So it's when we can change the substance of something. If we can change it back to how it was before, then it is reversible. If we cannot change it back to how it was before, then it is irreversible. Just remember that ir on the front means not reversible. Okay, so you can either watch it yourself, just click the link. Telegram. What's that? Click the link in Telegram or just watch it with me on Zoom if your internet's okay. Right, let's go.
Hi everyone, welcome back to SOS. I'm Simi and this is my sister Siri.
We're Sisters of Science.
Today we're going to be learning about irreversible changes and reversible changes. For example, melting. Today we're going to melt chocolate to see what happens when we melt it and then freeze it again. I think it's a reversible change. Do you?
Yes.
Then we're going to do ice. I think that ice is also reversible because you can melt it and freeze it again. Do you agree?
I agree.
Then we're possibly going to try cooking raw eggs. I don't think that's a reversible change. I think it's irreversible. Yes, let's get to it. First, we need the chocolate.
Where are we going to get the chocolate from?
Oh, it's a little snowman. Cool. Right, with this chocolate, we're going to mash them up in this bowl.
Bye-bye, snowman.
Oh,
I can't believe we broke the snowman.
Oh. Okay, right,
We
Siri.
still have the dog left. We're going to put this chocolate in this boiling water.
Make sure you get an adult to do that for you. Here's the chocolate. In it goes. Now we have some ice and we're going to see if this melts. Ow. Okay. So guys, now the chocolate and the ice has melted. The only question is, can we change it back to its original state?
Look, because we had green chocolate, it's gone green.
And this is the ice. It's turned into water. Reversible changes. Burning is an example of an irreversible change. So, here we have bread. Oh, I love bread. And we're going to put it in the toaster and then see if we can change toast into bread again. Let's do it.
What one do I put it in?
Push down the bit at the side and wait.
I don't like the pop now.
Bread has been made into toast. It has burnt. I don't think this is going to go back into its original state. So, it's irreversible. Ow! Now let's see another example of an irreversible change. Here we have some malt vinegar and bicarbonate of soda. We're going to put it into this and it will make carbon dioxide gas. So, first let's pour in this. Whoa!
Wow.
Fizz up! That's awesome!
Smell it!
How can they smell it? Little tip, guys, great for cleaning limescale off your kettle.
We need to see what happened to the water and the chocolate.
Let's take a look. Now we have the chocolate back and the ice. I've missed them so much. So, the chocolate has melted and also turned green.
Ooh.
So,
Because we had green chocolate.
also, this ice is completely frozen. It was water, but now they're reversible! Woo! So, on the count of 3, we stab the chocolate. 3, 2, 1. Oh my gosh, it's hard. This is what happens when you freeze such yummy supply. She's eaten the ice. She can't talk. So, that concludes our video for today. Don't forget to leave a comment below if you loved, subscribe so you can see more videos, and like. See you next time for more fun science. Perks of experimenting.
Oh, I wonder where.
Right, okay, everybody watch it. You're all unmuted.
Yeah, why there's Peppa Pig?
Yeah,
Wow.
why is there Peppa Pig? What's the Peppa Pig?
We're not watching
we
Peppa
still watch
Pig.
Peppa Pig.
We're not
We
watching
still
Peppa
watch
Pig.
Let's watch Peppa Pig.
Right, so reversible means when something can go back to its original state, how it was before. Okay, irreversible
Like
is,
egg. If we already burned it, we cannot make it back.
yes, when something cannot go back to its original state.
Reversible. There.
Right, so let's just mute everybody. Right, Some melting chocolate, reversible or irreversible?
Reversible.
Reversible. Nothing really changes. You can unmelt it and then it goes back to how it was. Soklang. Cooked rice.
Reversible.
Can you make, after you cook rice, can you make it go back to the hard rice it was before it was cooked?
No.
No. So is it reversible or irreversible?
Rice. The down one, teacher.
This one, irreversible.
Irreversible.
Irreversible. Okay. Remember that irreversible, ir means not. This is reversible. This is not reversible, but we don't say not reversible. We say irreversible. Sambat.
Yes.
Ice.
Reversible.
Reversible. We can melt it to go to water, and we can make it go back to ice again. Watanak.
Yes.
Lava. Or magma.
Magma, like
Yeah, like
yeah. But can you like be more specific? Like, will it change back to obsidian or something like that?
Okay, let's just say melted rock then. When you melt rock, will it go back to being rock again?
Yeah.
Yes.
If it's cold enough.
Yeah, well, as soon as it comes out the volcano, it starts to cool down. So is it reversible or irreversible?
It's Wait, what? Can you say that again?
So melting rock, hot rock that comes out of a volcano. So is that a reversible change or an irreversible change?
Hot rock from a volcano.
Yeah.
It can be cooled down.
And will it go back to being rock again?
A hot rock. Yeah, I think so.
Yeah, so it's reversible. You can reverse it.
Epic reversible. Reversible
Yes.
epic.
All right, it's reversible. Okay. Lavin. Cooking an egg. Cooking an egg. Is that a reversible change or an irreversible change? Cooking an egg, boiling an egg, or frying an egg, it doesn't matter. Can you make the egg go back to how it was when it was in the shell?
No.
No. So is it reversible or irreversible? Irreversible. It's not reversible. You cannot make it go back. Reverse, remember the word reverse means to go back. Like when you're in a car and you put the car in reverse, it makes the car go backwards. So reverse means to go back to how it was before. Okay, Panya. Boiling water into steam. Is that a reversible change or an irreversible change?
Reversible.
Well done, reversible, because the steam can change back to water again.
Yes.
Okay, well done, Panya. Win-win.
Yes.
Burning gasoline in a car. Is that a reversible change or an irreversible change? Burning petrol
Burning-
in a car.
Irreversible?
Irreversible, because it just changes into gas, and then the gas, you can't change the gas back to gasoline again. Chai Hawk. Turning bread into toast. Reversible or irreversible?
Irreversible.
Irreversible. Once you've made toast, you can't make it go back to bread again. Yukin. Setting fire to your house. Reversible or irreversible?
Irreversible.
Irreversible. Once you've burnt your house down, that's it. Your house is gone. Nothing you can do. Right, okay. Let's do some reading then. Soklang, can you read this part for us?
When materials are heated or cold, they may undergo change. Their change may be temporary,
Permanent.
or permanent. We can also say that change can be
Reversible.
reversible or
Irreversible.
irreversible. The temporary change is reversible. A material that has undergone a reversible change can still return to its initial form. No new substance is formed. Such a change is also known as a physical change.
Well done. Well done. Okay, so a reversible change, that means that if it can go back to how it was, then that change is temporary. Temporary means like a short time. If you cannot make it go back, then we say that change is permanent. Permanent means forever, or for a very long time. All right, well done, Sokleng. So I'll just read. Oh. So, for example, when solid chocolate is heated, it melts to form liquid chocolate. The liquid chocolate can be cooled to go back to being solid chocolate again. So this is a reversible change. No new substance or nothing new is made. It stays chocolate. It just changes from solid to liquid. Then it goes back to solid again. Butter, again, when butter gains heat, it becomes soft. The soft butter can go hard again when it is cooled. So again, butter, melting butter is a reversible change. No new substance is formed. Ratana.
Yep.
Melting ice cream, reversible or irreversible?
Reversible.
Yes. Ice cream can go back to being ice cream again. Right, okay. Ratana, while you're there, you can read this bit for us. A permanent change.
I don't see it. Oh, here. A permanent, what is a permanent, permanent. Yep. A permanent change is
Irreversible.
Material then has undergone An irreversible change cannot return it to original from a new substance. It formed because of the change. So a change is also known what that
Known as a chemical
chemical
change.
change.
Chemical change, yes. Okay, well done, Ratana. We call it a chemical change because the chemicals that it is made of, the chemicals themselves change. If we talk about chocolate or butter, the chemicals don't change, only the form. It only changes from a solid to a liquid, and then it goes back to being a solid again. The chemicals don't change. But with an irreversible change, the chemicals that it is made from, they change. And when the chemicals have changed, you cannot change the chemicals back. For example, a chicken, if you cook a chicken, that's it. The chicken is cooked. You can't make the chicken go back to being uncooked again. It's a bit like having a chicken that's alive and then you kill it to eat it. You can't make it go back to being alive again. That's an irreversible change, unless you were unless you had a lot of power, like, I don't know. Right, okay. So when raw meat is heated, I'll just read this because we're running out of time. When raw means not cooked. When raw meat is heated, it becomes cooked. The cooked meat cannot be changed back into raw meat. This is an irreversible change because a new substance has been formed. How do we know that it's a new substance? Well, you can't eat raw chicken. You can't eat chicken that's not been cooked because the chemicals in raw chicken will make you very sick. But you can eat cooked chicken because the chemicals have changed and now the chemicals are safe to eat. So you can eat cooked chicken, but you can't eat raw chicken. That's how we know that the chemicals have changed. Okay, but we have this, when you burn paper or when you burn anything, that's an irreversible change because a new substance has been formed. Leaves, for example, dry leaves, you can burn them, they will turn to ash. Ash is a different substance than dry leaves. Ash, you cannot put the ash back together to make leaves again. Samay, can you read the bottom bit for us? Besides heating and cooling.
Besides heating and cooling, making material can also cause them to change. These changes may be reversal or reversal.
Okay, well done. So you can mix things together to, like the girls did in the video, they mixed vinegar with a powder called bicarbonate of soda. But when they mix them together, it is an irreversible change. You can never pull the things apart. But if you mix water with oil, that is a reversible change because water and oil, they don't mix together. The oil will sink to the bottom and the water will stay on the top. Right, okay. What are mixtures? Win-Win.
Yes.
Do you want to do some reading for us? Can you read this bit for us?
Yes. When different substances are combined, such that no chemical change occurs, a mixture is formed. The properties of the individual substances in a mixture do not change. This is salad. It is a mixture of vegetables, cheese cubes, olives, and onions.
Okay, Win-Win. So we've got a salad here. Okay, we've got lots of things mixed together. Is that a reversible change or an irreversible change?
Irreversible change.
Can we not take all of the bits out and put them?
We can put them back. Put them
Yeah,
on.
but you can't really, like, once you've cut the tomato, you can't put the tomato back together again.
Yeah.
Once
That's
you've
what I
pulled the
said
lettuce up.
about filling up irreversible.
Yes. Well done, Win-Win.
Thank
Okay,
you.
so we got. You're welcome, Win-Win. Anytime. Mixtures are all around us. We have lots of mixtures all around us. The water in the pond is a mixture. It's a mixture of many things: bacteria, life, fish, tadpoles, dead leaves, rocks. The air around us is a mixture of different gases, oxygen, carbon dioxide, and nitrogen mostly. Soil is a mixture. There's all different chemicals in soil that make soil. Okay, let's move on to the next page. How can we separate solids? Panya, can you read this bit for us?
How can we separate solid mixture? Both solid mixture can be separated to get the original substance that there are different methods of separating these mixtures, and they are chosen based on the properties of the substance.
Carry on, what's the girl saying?
Oh no, I can't eat the salad. I don't like cheese. No problem, Rita. I can remove the cheese cube from the salad for you. The cheese cubes are different in size, shape, and color from the rest of the ingredients in the salad above. They can be easily separated by hand.
Okay, well done, Panya. I think your microphone's a little bit funny today. Okay, so we can, most solid mixtures, we can separate them. For example, if someone doesn't like cheese cubes in their salad, we can take the cheese cubes out. But most liquid mixtures, we cannot separate. When you mix two different liquids together, you cannot separate them. Sometimes you can, like water and oil, you can, but most of them you cannot. Right. Let's move on to the next page. Right, this is going to be your homework, but this is going to be your homework for tomorrow. You don't have to do it today. There's only one homework today, which is Superminds. Right, who else wants to do some reading? What an act.
Yes.
When one of the substances
when one of the substances is too fine to be separated by hand, sieving can be used to separate the mixture. A sieve has holes that allow smaller particles but not larger particles to pass through. A mixture of berries and dirt can be separated when using a sieve to remove the dirt particles from the berries. When placed under running water, the dirt particles will be drained out from the sieve, leaving the berries in the sieve.
Okay, well done. Maybe you say sieve with your American accent. I don't know where you get your American accent from.
Sieve. Is it sieve?
Sieve.
Sieve.
Like just S-I-V, sieve, that kind of sound, sieve. Maybe they say sieve in America, I'm not sure, but in the UK, we just say sieve. Okay, so you all know what a sieve is. I'm sure all of your mums use a sieve when they cook. You use it for many things. Yeah, they're very, very common, especially for cooking. Yeah, in English, we call this a sieve. All right, okay, well done, Watanabe. So a sieve, the reason why we use a sieve is because the holes are very small, so anything too big doesn't go through the hole. Anything big, anything very small will go through the hole. Have you ever wondered why we have hairs inside our noses? Well, I would imagine most of you at your age, you probably don't have hairs inside your nose. But one thing you will notice when you get older, especially the boys, when you get older, you will have a lot more hairs in your nose, and you have to pluck the hairs out. Otherwise, they don't look very nice. But the reason why we have hairs inside of our nose is so that they act like a filter, so that any dust or things like that in the air that we breathe in, the hairs trap the dust so that we don't breathe the dust into our lungs. And actually, that's what bogies are. When you have bogies in your nose, that's your nose doing a very good job. That's your nose stopping all of the nasty dust and things in the air. It's stopping it from going into your lungs. So if you have bogies, it's actually very healthy. It means your nose is doing its job properly. Just make sure you don't eat them. Right, filter bags in vacuum cleaners. I don't see people use vacuum cleaners very much in, okay, in my country, many people use vacuum cleaners because on the floor, we have a lot of carpet, a lot of rugs on the floor. You don't have them in Cambodia because it's too hot. If you had carpets in your houses in Cambodia, your houses would be far too hot. That's why you have like stone floors here. But in houses where you have a lot of carpet, we use a vacuum cleaner to clean the carpet, and they have filters in as well. Right, Chai Hawk.
Yes.
Yes, can you read this bit for us?
Besides separating by hand or
Sieving.
There are other methods to separate solid mixtures. A mixture of
Magnetic
and non-magnetic objects can be easily separated by using a magnet.
Okay, well done. This is often used in recycling. When you throw your cans in the recycling bin and all of the rubbish goes to the recycling place, they will use a magnet because cans, drink cans, soda cans, they are magnetic. So they run everything underneath a magnet. The magnet picks up all of the magnetic things, and then everything that's not magnetic goes underneath. So that's how they separate the tin cans and things like that. Okay. Samay? Right, Samay, where are we now?
Why you unmute me, teacher?
Who have I unmuted? Oh, Panya. Okay, sorry. Samay, can you read the next bit?
Yeah. Eric cannot see the salt partition that he added to the glass of water as they have discovered. This means that the salt particle has been evenly distributed throughout the water and cannot be seen with the naked eye. However, the salt is still there in the water. How can Eric confirm this?
Okay, well done. Do you know this word, Samay? Particles? What does particle mean?
I don't know.
Okay, a particle is the very, very, very tiny, like salt, for example. Salt is made up of different particles. Particle is the very, very small things that everything is made from. Do you know what this means, Samay? The naked eye? What does that mean when we see that?
It means it has no eye.
No, it means it says it cannot be seen with the naked eye. That means that you need something special in order to see it because it's too small. if something can't be seen with the naked eye, that means normally you can't see it. You need something to help you to see it. Okay, naked eye, like no glasses, no microscope, no telescope.
Zooming glasses.
Say again.
I said zooming glasses. It's like
Yeah, a microscope. We often say a microscope.
I said zooming.
Zooming, we don't normally call them zooming glasses. We call them microscopes. Right, okay, we've got one last page. How long we got? 4 minutes. Who can read fast? Who can read quickly? You can.
Yes. Wait, teacher,
You can.
Yes.
What are you doing?
My sister watching TV. I cannot hear anything.
Can you not go to another room?
I think what's mine. She put the volume to 64.
Right, okay. Is it not possible for you to go to another room? You can? Okay. Who can read quick? Sambat,
Yes.
can you read this page for us in 3 minutes?
All the whole page.
Yes, 3 minutes.
Okay.
Go.
Zoom in. Oh my god. Solid that can dissolve in
Dissolve.
liquid. Okay, dissolve in liquid or
Soluble.
soluble. So, salt and sugar are soluble in water. Once dissolved in water, they cannot be seen. The resulting mixture is known as a solution.
Okay, and this bit here, solid.
Solid that do not dissolve in liquid or in I cannot see it.
Insoluble.
Insoluble. Sand and chalk powder are insoluble. Insoluble. If you mix sand or chalk powder with water, they will be visible.
Okay, and the last bit.
How fast and solid dissolve in liquid depends on a few factors such as temperatures and size of the solid particle. There are several ways to make a solid dissolve faster in liquid. We can hear the solution stir it or crush the solid into smaller pieces. As more and more of the solid is added to liquid, the solution reach on a stage where no more solid and dissolve. When this happens, we say the solution is saturated.
Okay, all right. Well done, Samba. Very good. Okay, we're going to run out of time. Just to this word here, dissolve. Dissolve is when you put like a powder in a liquid and you stir it, and then the powder disappears. Like sugar, when you put sugar in coffee and you stir the coffee, the sugar disappears. You can taste it, but you can't see it anymore. That's what the word dissolve means, okay? Salt and sugar, you can dissolve them. Chalk and sand, you cannot dissolve. If you put it in water, it won't mix with the water. Right, okay, we're going to run out of time. There's no science homework today. Only Superminds is the writing, so it's in Edmodo. You just